So I can invite my next speaker, Jim. Please join us and please tell us what you're going to talk about, because at least from the heading, I can see from barcode reading to vision deep learning, seemingly an easy task.
That's the plan. Yeah, we'll talk about that. We'll get started. It's just a different dynamic. So one of the fastest growing parts of the machine vision world is barcode reading, and some companies it's actually overtaken a lot of their machine vision sales. So we'll talk about a topic today that kind of links that to deep learning. It's something not everyone really realizes or could witness. A lot of the applications we'll talk about today are going to be more simplistic or easy. It seems like when people talk about deep learning applications, they're very challenging. And people always find you the hardest thing to do. And those are very hard to implement for everybody. And when you're trying a new technology as an end user, it's important to pick something that you're going to be successful with. Because if you're not successful early, you're going to tell everyone for the next 10 years how bad deep learning is and how horrible it is. Think about all the stories you had from the machine vision world from the early ages. Oh, we tried vision once. It was so bad, so horrible. It's all terrible. It's a black science or black arts. We don't want to use that anymore. We want to focus on doing some of those things and making sure that that doesn't happen with deep learning, because deep learning is really cool. It's really exciting. When deployed properly, you could do it. The panelists today talked about some of those hard things that are doing. The annotation, I did say people are really horrible at it because they put the wrong people on it. So some of the technologies you saw, they take that away, and that's really a focus. It's a great spot to start for people who want to get into deep learning. We'll jump into the presentation. I'll figure out this clicker here next to the arrow. The big green one, right? Yeah. My deep learning's better. This is going to be the most important slide to you. And the least important. The least important part is me. I'm Jim Witherspoon, product manager at Zebra Technologies. We've been in the technology business for 50 years. Most people know about us like barcode readers and printers. We've joined the machine vision world about 2 years ago. So we're into the space. Now, why this slide is important is because after listening to me, if you're tired, we have free coffee over in the Zebra booth, free cappuccinos. If you mention my name, they'll give you a double. So that's good to know. So most important slide of the day is probably right here. I'm from Detroit, Michigan, too, so it's great to be in Germany. It's my second time here. I love the show, love the people, and I love this industry. So a quick few definitions. What is fixed industrial scanning and image-based barcode reading? People who have gone to the grocery store, everyone can kind of understand what this is. If you've done one of those self-checkouts where you pick up the bag of frozen peas and scan it, that's kind of like a barcode reader, right? We do a little bit better. Those frozen peas could be a real challenge, so we do have good algorithms for that. But needless to say, it's any kind of reading of 1D or 2D barcode reading. It's a subset of machine vision. As I said before, it's one of the fastest growing. The pandemic has done a lot of things and changed the markets. Any transportation logistics company needs to get things done faster. Now, Zebra is one of the largest manufacturers of handheld scanners in the world. The former product manager is here. I'm sorry, because everyone's moving to fixed industrial scanning because they find that picking up a barcode reader is inefficient. And with the fixed industrial scanning, I'll show you a couple slides how much more efficient it could be. But the second definition here is machine vision. This is the standard stuff that's been around forever. This is that deterministic. It's a blob tool. It's a pattern tool. That's what that style of machine vision, if I hit that, I'll talk about here. And then you have your deep learning, computer vision, and AI. And there is a hierarchy to that. I'm not going to get into it, maybe because I'm not smart enough to explain it. But that's that neural network piece that all the gentlemen have been talking about, how you create the models and go with it. Conveyor belt scanning. All right, now we're going to jump in and talk about the barcode reading. This conveyor belt scanning, it's an original application that's been there. It's pretty common in the industry. Boxes go by, and you read envelopes that go by. And scanners are set up in an environment to read each and every one of those. It's one of the most popular applications that are out there today. Things are changing in these applications as well, and I'll get into that. But any package, how many people use Amazon, FedEx, DHL, everybody, right? All these packages are scanned multiple times, so they're highly traced, and so they get them to you. They created this thing called next day shipping or same day shipping. The only way you could do that is to have great systems that allow you to know where your stuff is at all time and get those to you quickly. So that's why these systems are becoming more important and more available into the market. People want to put more and more of these systems in. This is the one that's the fastest growing. This is what I talked about, the handheld systems going away. This is fixed overhead scanning. This person on the screen here takes a box. I can never figure out if he's putting them on the pallet or off the box. But in this particular picture, the only thing that matters is there's a scanner up above, that little green thing up there. He's passing the box underneath it. He no longer has to stop, pick up the barcode reader, and then move on. The other thing this poor gentleman would do is he would set the barcode reader on the box. He just scanned, that conveyor belt would go, and then the guy had to get his still track shoes on and go out and get it. So all those types of technologies of fixed industrial scanning are fixing this application to make this process more streamlined. So now that we've looked at that, those are the technologies, and we'll look at 3 different aspects. This is that different way of thinking that's in the slide deck that we talk about. Things have become easier and more cost-effective and faster throughout the world. So if you look at the first section, it's called overspec it. And I'll show on the next slide a little bit more about that. But technology always comes down in price, right? So that's number one. So back in the day, VGA was a super high-resolution sensor. Then we went to SVGA and so on and so forth. Now 2 megapixels kind of the standard where everyone's looking at. Now 5 megapixels is becoming more important. The cost of those technologies have come down. So overspecking technologies become more cost-effective for these types of solutions. Processing speed, everyone knows this. Not that long ago, people had flip phones or phones they carried. Now you have phones that are super fast. The same thing with technology and cameras. Processors are becoming faster. Things are becoming more efficient. More memory is available than there ever has been before, right? And this technology trend is going to continue. So now we have gone from turtle speeds to rabbit speeds because now we have faster technology and faster processes. And then the camera there, what that indicates is that technology of growing that. You know, the VGA to the 5 megapixels. There's 12, 20, and 30 megapixel smart cameras out in the market and barcode readers now. So that technology has grown quite a bit. The second stage of this is probably one of the most important. And everyone talked about having image sets. The simple thing you could do is take any barcode reader or any system you have today and start storing images. You can never have enough images. You could always try to do things with them, set up neural networks and do deep learning with them later. But without those images, you can't do anything. So it's very imperative that you store these things. Put them on the cloud, put them on a local server. There's always a conversation whether people don't like the cloud or people like on-premise style storage. From this aspect of what we're talking about here today, it doesn't really matter. Just save them. You're already paid for all the money and all the investment into putting this fancy scanner out there that can take images. If you don't store the images, you're wasting some of the cool technology that's out there. And step 3 of this is IoT it. And what that means is look for technologies that have things like multiple Ethernet ports or allow that integration to be easy. We have a scanner that has 2 ports. You could use a PC-based vision system that has multiple ports. There's a dynamic in the world where there's an IT and OT entity at all the end user facilities, right? And they don't get along, right? It's not just one letter difference. They really don't like each other, right? So if an OT person goes out there, that's a person who's doing the controls in the plant and wants to put some data files on something. He doesn't want to put it on his production network. That's because a 5 megapixel image is quite huge. If I'm running a production line with key critical information, I start sending jumbo frames on it, it's going to screw up the system, and they're going to have downtime situations. So that poor gentleman has to talk to the IT department. The IT department hates anything that has to do with anything that's OT. Right? It's just lots of data that's getting there. You're going to screw up our systems. You can't put that on our corporate file systems. So those 2 guys get at it and fight it. So look for technology that has this type of technology where you can segment and split. So you can say, hey, this port is controlled just for IT, this port is controlled for OT, they get along and they're all happy, your customers are happy, that's a good thing. So that's the IoT it section of this particular slide. You'll see at the top, this is the not rocket science guarantee. You probably would have all figured this out yourself. It's also not rocket science because this is the 3rd day of the show and we've all been standing for 8 hours a day. Everyone's kind of tired, so I didn't want to get too technical. So a simple concept, and I'll revisit this slide again later to drive it home. Back to the overspec it. This is my great PowerPoint presentation skills, and you can see I have boxes, and watch this cool technology. Boom, a box just appeared. That's about as far as I could take my PowerPoint skills. But what it does show us is this was how it was done before in the past. Someone would call up and say, hey, I have to read a barcode. In the past, someone would say, oh, that's great. Here's a VGA sensor. Let's put it on your box. Let's read that barcode. That's what that solution would look like. Next, the 1.2 became very popular. People are like, yeah, this is great. Now I don't have to fixture my box as much, right? It can have slop, it can move around. Yeah, I can be sloppy. You don't have to worry about key fixturing. That's when the 1.2 came out. Now we're at the era where 2.0 is becoming popular. And this is what's cool, is because now once you have a full-size picture of a box, you could do some cool deep learning, which I'll show you on some other slides. For extra credit, if you really want to have fun, you can take a 16 megapixel image. Now you can start looking at the sides of pallets and start doing some inspections on pallets, which you can see as well. All right, so what is barcode reading? All right, so barcode reading here is, again, we'll talk about the 2 megapixel. If I just want to do barcode reading, I take a 2 megapixel image or camera sensor, put it on right next to the conveyor belt. You can see I could get this nice, good image up here, and I can read the part number, serial number, manufacturing date, all that key information. I could take that, I could send it to any system I can. Those systems have been around forever. They're fantastic. Now, the cool part I talked about is saving the images. If I save that image, I now have a picture of that particular box. And I can save all those to the cloud or to a local server, and now I can start creating deep learning models. The first one I'll talk about is anomaly detection. How many people go to the store and buy the box that's all mashed up and beat up? You do? You buy the mashed up, beat up box? If it's on sale, discounted, right?
Sometimes you don't have any option.
That's right. You didn't have options. But when times are good, that's the last box that gets sold. That's that piece that gets discounted, that open box item. That costs everybody money. No one wants to have that beat up box. The product inside could be perfect. There's box engineers that spend countless hours making sure that nothing's going to get damaged, even the boxes, but customers don't want to buy it. So when you have defects and anomalies that leave your plant that are damaged and scratched, people don't want to buy it. So you could go ahead and set up an anomaly detection. This particular example would show you a solution where you could take only good boxes. Someone could go and select all the good boxes from that day's shift, throw it into a model, and then all the anomalies would show up and pop up. That way you're not shipping bad boxes from the beginning, right? Your chances of those boxes getting damaged or further damage could happen. However, they're not leaving your facility damaged, meaning you're cutting down on the amount of returns you're getting back, and your customers are going to be very happy because they're not buying that scratched up boxes. Now, if we look at the next one, this could be a segmentation example. It's great to know what shipping labels you have on there. And sometimes, let's see here, I'll hit the button there, I'll show them all. You can identify which ones are on there. This is key and important. If you're shipping product, and we have a special training at our company we have to take, you can't ship batteries without like a 4-day training class. It's so important because if you do, the fines are immense. Right? You have to make sure any kind of hazardous material, anything with a battery has to be handled specially. So if you mislabel a box with that or ship a box that has batteries that isn't marked with a battery, that could be a huge fine. They could put you on containment, which means you have to have somebody stand there and look at all the boxes going by and hope that person is good and they show up all the time because you can't even find people to work anymore. And thirdly, they'll stop you from quoting new projects. If you can't supply things properly, you're going to put on a containment process where you can't even quote to do new products or goods for people. So it's a serious thing. Sometimes I think when you put a fragile sticker on the box, the person delivering the box beats it up even more, but it's still important to check to make sure it's on there because people feel safe when there's a fragile sticker on your box. So this is that kind of deep learning where you say, hey, I know what's on that, we got the right things going on, we're good to go. It's not mislabeled. Another one is classification of a box. So believe it or not, I know the world has many different people who like different labels. EMEA, North America, Latin America, all have these different labels. So there's all sorts of configurations that people and processes have to do to make sure the boxes are appropriate to be able to be sent to each particular area. So this type of classification, you could train the different boxes that are supposed to go to different areas and use deep learning to do this, right? So this is kind of cool. And these aren't hard applications. Could you do them with standard machine vision? You could, but there's more complexity to them because this could be shrink wrapped all of a sudden, or this could be on a mixed pallet. So there's a lot of extra things that go into this. Object detection is a great one. You could go out and find all the shipping labels that were out there. Now I could do a count. I could say, hey, there's 5 pieces on this pallet. Is that the right number that's supposed to be on that pallet? Sure, I could pass it along. I could check to make sure it's the right shipping label on that box and in that pallet for a mixed load. Very important operation for people. Mixed pallets are one of the hardest things to do actually in machine vision to read barcodes on because the boxes could be stacked any orientation. They could move a little bit. So deep learning lends itself to be used very, very well for these types of applications. Here's a second one that talks about object detection. We talked a little bit about some of the segmentation of it. I can now look at my mixed pallet and I could identify and find things like the battery sticker and make sure that's on there. Sometimes you can't ship a mixed pallet unless they all have batteries or they don't. This would indicate that and allow people to be able to find those types of solutions. So very important there with that type of object detection. So the different way of thinking, let's just touch on it again, right? Over-speccing it makes sense, right? The cost of this technology has come down greatly, right? In the past, a 5 or 12 megapixel barcode reader could cost you $8,000 to $12,000. Today, that could be $3,000. So that cost of that technology has come down greatly. The processing speeds have come up greatly. These things are now fast and be able to process things at 60 frames per second or higher in some cases. Right? PC-based systems are now starting to be used out there. You could get up to 250 frames per second on some really high resolution stuff using coax express. So the technology is there for everybody that's out there because of those speeds. The resolutions, like I just talked about, they're there. 30 megapixel coax express stuff, even higher. I mean, that's ridiculously fast. It allows you to get that stuff through and do these acquisitions and reads really quickly. So that's the over-spec part. We go back to that store piece. If you leave besides the coffee, the next important thing here is to store your images if you have them. Because then you could give it to anybody out there in the industry and say, hey, I have this concept I want to try. I want to see if I'm able to do this. Here's some images I stored. What do you think? What kind of models can we create? What can we do from there? And that can be stored either locally or on the cloud. So that's really cool. And then that third piece is IoT it. Make sure you have pick technology that makes it easy to integrate, easy to implement these sort of solutions to make things easy for everyone in the short term and the long term. If you do all three of these things, you're going to maximize your investment in any of the technologies you have there. You can also go back today and maximize the investment you made in the past as well. So it's very important to be able to do that. So again, hopefully that wasn't rocket scientists and everyone figured it out and could follow. That's my last slide. I just want to thank everybody and answer some questions. So thank you.
Thanks. That was so, I mean, a little bit of humor goes a long way.
It's the only way I could do it.
So that was my highlight. I mean, it was funny. It was still understandable. Great presence. You have questions?
Don't let the handheld guy ask me any questions, so please.
If they don't have questions, then I have some.
Oh, let's go. I'm ready.
So the first point you hit back home was the IT/OT thing, because that's what I struggle with all the time. And because I work with standardizations, OPC UA, if that rings a bell. The problem is people come and ask, what do you want to provide with the OPC UA interface and what you leave out of it? How do you decide?
Yeah, it's a challenge, right? So we try to educate, right? That's the number one piece. We try to teach people the best ways to be able to put things in and out. So we actually have a team of engineers who will sit down with customers and work through it. And we also have we rely heavily on a partner community that we try to train. And it's an individual case-by-case basis and best practices, right? Don't take one part and create a bunch of defects on it as you keep going and say that here's my model or here's my images. Some of those best practices, we have lists of like 10 or 20 things that we recommend to people when they're trying to annotate and do those sorts of things to move forward. Does that kind of help your question out? Or?
Yeah, sure. Because people want to transfer images that the MES is not really interested.
Right. Yeah.
What images are being transferred? Yeah. The MES is required on quality inspections, carbon footprint, for example, something like this.
So it's part of the process. Now I'll continue on. You start with as much as you can, and then you tweak it down. Eventually, you don't need to capture every good image necessarily, right? Yes. So you could start, and then as the system goes, anomaly detection is the easiest one to start with, right? Here's all my good images, and now you start shoving all the anomalies in a bucket. You could go back and label and classify those things ever. So it's kind of a process of how you could do it. If you start simple and start with an anomaly detection, then you could lead into the classification, segmentation, and so on and so forth.
I would take the cue. I would ask the same question, but I asked the same question that I asked to Fernando. But in this case, that should be easier to answer, right? So if I would go back to the same question that I asked him, but in this case, it would be easier because I don't really think that the customer would mind if you use the pictures that you're using because they are standardized labels?
Yeah, exactly right. So a lot of this technology is available, or not technology, a lot of the parts are available to the market already. You could go grab a cereal box today and create yes, absolutely, you could do that. Some of the this allows you to do things like pre-trained models, right?
Yes.
And this is kind of, one of our goals is to make vision for the masses. That's kind of what we always talk about. And to be able to do that, we want to create pre-canned solutions and pre-canned things. So we can use that. We can use that technology. We could grab pictures of already released parts and boxes, take those and try to get somebody a starting point. So yeah, absolutely.
So NDA problem is not so relevant
so
in
much,
this case.
It's not like a special thing that's only in a certain car. These are standard box. It's a cardboard box, right? I mean,
exactly.
Not much intellectual property in a cardboard box.
Perfect.
Unless the cardboard box people are here, I apologize.
Perfect. Thank you for the great presentation.
Yep,
thank you for answering the questions as well. Please give a round of applause to all my speakers once again before I take your leave. Thanks a lot.